Hello, my name is Mauro Spagnuolo. I'm working as planetary geologist in Argentina at the Institute from UBA CONICET. Today I'm going to talk about how to download and process some of the Titan data, or better say, the Cassini-Huygens data from Titan, in particular radar data. As you well know, Titan has a very thick atmosphere, so we can't see directly the surface, as the same case as Venus. The Cassini-Huygens mission had some cameras that could penetrate the atmosphere with different channels. We could start seeing some surface features and do some spectroscopy and compositional analysis of the surface. But today I'm going to talk about how to download and process some radar data, because it can penetrate the atmosphere. It has properties directly from the surface. It works at day and night. It has very advantages. And Cassini-Huygens mission took a synthetic aperture radar that worked in Q band, and took a lot of images, as you may see in this map. This is all the radar data from the mission. There are some gaps that hopefully will be filled in future missions. So let's say we want to make a study of this particular area. You can see that there are some overlapping flybys. Each of these stripes is one image. So let's start by how to get access to this data. Oh, sorry. I will be back to that then. So first thing, you have to access the PDS cartography and imaging science node, pds-imaging.jpl.nasa.gov. There you go to the data portal, and at the very top is the Cassini-Huygens mission, and then you go to the radar archive. The archive is very well explained. The team did a fantastic job commenting and putting in order all the data. So let's say I want to look for the radar data from flyby T21. I usually just search in the browser for that name, because each flyby has the letter T with the number, and the higher the number, the higher the date that image was taken. So the archive is duplicated, so it's the same if you enter here or here. And you can go to the README file. It has all the information you have to understand the archive. In particular, I'm going to go to data, BIDR directory. Here is the SAR data, and you have a lot of files, so I recommend to read carefully the README files to know which one you have to download. I will download the BIFQI file because are the highest resolution radar images for this particular flyby. That is T21. You have also here lower resolution images from the same area. So you download the .img file together with the label file to your working directory. And then, sorry, let me go here. Here we are. I'm going to use ISIS. I activate ISIS with conactivate ISIS. I mount my, my working directory there. And then I'm going to ingest the .img file into ISIS with PDS to ISIS from the name of the file you downloaded to whatever name you want as output. As you may see here, maybe are you seeing here, you have the downloaded files and the generated .cube file. Then we want to project these files into Titan. So we are going to do that with map to map command, but first we have to generate a map template file that has all the projected information. In particular, we want to do this because I will be downloading 3 images, and I want to be sure that all the 3 images are on the same projection. So I create this file, my simp.map file. Here you can put whatever name you want. Also, with map template command, map equal your name, and you specify the projection, in this case simply cylindrical, center longitude, target Titan, and longitude domain from -180 to +180, and positive west. So here, basically you need these 3 commands: the PDS to ISIS to transform from .img to cube file. You generate a map template file, and then you apply map to map from the cube file, and you call the map template file. Here, note that I'm using the full path to locate the file generated with map template. And there you are. You have your image projected into Titan. Then with QView, we can see the 2 images. This is the image after PDS to ISIS, and this is the image after map to map command. I did the same for 3 images because I'm interested in a particular area that where the 3 images overlaps, and I don't want to work with the full images. I only want the overlapping area. So as I know the coordinates, I'm going to use again map to map, but this time I'm going to specify the minimum latitude, maximum latitude, minimum longitude, and maximum longitude of the area I want, and voila, you have the only the area that overlaps in the 3 images. Note that there are some difference because of the different angle of observation. And then I want to convert these cube files into geotiff. I'm going to use GDAL. So with GDAL translate, minus of OF from output format, the type of files, in this case geotiff, input file, output file. In the newer version of GDAL, minus of F, geotiff, it's not strictly necessary because understand the output image type from the extension. But I do this from the 3 images, and I have this same 3 images into geotiff. Radar has a lot of advantages, but basically to understand a radar image, you have to know that a smooth surface is going to be seen as a black area, and a rough surface is going to be seen as a brighter area. Also, the darkness or brighter of the image depends on the dielectric properties of the material, but basically one can assume that a brighter area is more rough. So here is the area that I'm interested on. And you can see very bright areas, and these areas are also the highest ones. So these are the mountains, these stripes are dunes. Here you can see, you can, I overlap the three passes to see in like pseudo color, and start mapping just by morphology and brightness and specific characteristics like these dunes, like this dark smooth area similar to playas, some channels with fan at the very end, and so on. And as we have an overlap of three images, I will show a very easy and fast automatic classification in our studio. Let me pause and back again in a second. So I'm back, and let me show you first in QGIS. Here I have, as I told you, the three images geotiff files. I can open them in QGIS. There you are. So you then can play here with the maximum minimum. I like to enhance a little bit here. Sorry. There we are. Forgot to do that. There we are. So in our studio, there is a very simple set of commands. I'm going to use only two libraries, raster and cluster. And here, basically what we are doing, we are going to open and make a stack image with the three geotiff files. Then I will like to write that image, and I will do a k-means analysis. I'm going to specify 4 centers. That means that there will be 4 classes, placed 4 classes that the software or the algorithm will recognize that has similar properties between the 3 images. Here I specify the algorithm, but just using this line, I generate the result, and I'm writing the result. Let me do this really fast, but here in result, oops, sorry, and here in class, we have the file. Sorry for that. We're going to go to QGIS. And if we go to the symbology, We are going to set values, specific values, classify, and there we have the 4 classes identified by the code as that has particular properties in each set of 3 images. And for example, you can use transparency, set some transparency there, and there you are. And then with this, you can go back to your map. And for example, here we decided to only get 4 classes as specific geomorphic units. That's all, guys. Thank you. Bye-bye.